PhyloCommons, community storage, annotation, and reuse of phylogenies.
Hi. Phylogenetic trees, probably many here are aware of, are published at a very rapidly increasing rate. And that doesn't just apply to the size of the trees, which are also getting larger and larger and now reaching to the even tens of thousands of tip nodes, but also applies to the taxonomic coverage they have for any particular group. And it really goes with the whole tree of life. Sorry, this is actually the wrong slide. Where did I get there? This is the slide. Goes from mammals or bacteria or plants. It really covers the whole tree of life. And so these phylogenies also have many applications across many biological areas, particularly in any kind of comparative analysis. And that goes from investigating the evolution of, for example, metabolic pathways to discerning evolutionary rates. I see it's on our advance. To discerning evolutionary rates and also to looking at how ecological communities evolved over time. And yet, surprisingly, even though there's a lot of production of phylogenies and a lot of demand for them, the reuse of phylogeny is surprisingly rare, as these authors found in a study last year. And so the reasons for that are, for one, that digital archiving lags behind is actually surprisingly low. Less than 4% of all published studies are actually archived in community repositories or data archives, such as Treebase, even though those exist. There are more problems than that. Phylogenies can be behind paywalls. They're often poorly annotated, and they're often also only available in the form of images rather than in the form of text formats that are actually amenable to analysis. And so that's where PhyloCommons comes in, which is the tool and the piece of software that I'm presenting here. And it's inspired by the one exception to this disappointment finding that I reported previously. And so PhyloCommons, that tool is called PhyloCommons. So it expands on the ideas where it addresses one of the main use cases where people in many comparative analysis start off with a situation that they have a list of species in the comparative analysis, and what they need to find is a tree that has all of them in the tips and that is produced according to specific methods, maximum likelihood or others that are applicable and are produced according to best practices. And so PhyloCommons is a platform and a tool and an underlying infrastructure law that allows a community of various sizes to do that. Whether that's a larger community, a whole field, or just a laboratory or an individual investigator. And so it has a discovery interface where you can put in a list of species. It will do resolution of those names according to taxonomies that you can choose. And you can apply filtering criteria as well. And what you get back is a list of matches, both previously published trees that have full matches. It gives you taxonomies as well, if they've previously uploaded, and it also gives you a number of partial matches. And so then it has a visualizer. You can download this in various formats that you can then subject or use for the analysis tools that you have. There's support for annotating the data as well, using different ontologies. What we're currently using here, for example, is the comparative data analysis ontology, as well as the ontology for the minimum information about the phylogenetic analysis standard, which is a minimum reporting standard that tracks provenance and the methods used in generating the alignment, generating the tree, and so on and so forth. And so just a quick example use case, just to illustrate that this isn't really necessarily a tool just for a whole community or for a simple server. And so Ben, one of the authors here, or actually the author of all the software, I should say, is an ecologist listing follows in the community assembly patterns. And so there's a number of species that he has from a species checklist, and now he needs to know how these are phylogenetically related. One way to do this is using a manual and scripting approach, which is painful, takes a lot of time, and also results in only partial matches. The other way is using PhyloCommons, which is this interface that I showed you before, but also uses synonym matching, which is pasting the list. You can see the trees that match, you can filter them further, and you can back a tree that has all of the desired species as tips. All right, and let me just close with that in thanking. PhyloCommons is actually a product of 2 hackathons caused by, organized by and supported by a working group at NESN called Hackathons Interoperability and Phylogenetics, or HIP in short, and try it out. It's posted on GitHub. There's a working instance, but it's also easy enough to stand up on your own. Thank you.